there are just two neural networks. One is the generator, the other is the discriminator. The generator is generating fake images but try to fool the discriminator that this is a real image. And then the discriminators begin to say, no, this is not a real image. But in the process of doing that, the generator is learning from the discriminator feedback, therefore improving the quality of the generated data over time. Hello everyone. In this video, we are going to discuss 10 best methods for generating synthetic data. We will define what synthetic data is, we will discuss the benefits, how it is being used, and then we discuss the 10 best methods, backing them up with the mathematical formulas behind. And this is really important because you can be able to understand how it works and use it in your own project. It is important to study and understand how synthetic data is generated because it is what leads to fake media, deepfakes, misinformation, disinformation, etc., etc. It can have influence in elections, like in politics. It can even disrupt public health. It can even cause political, economic. It can create negative economic impact because people can use synthetic data to generate fake financial reports. It can also be able to use for social polarization in the world. And there are so many other issues that can come from deepfakes. So it is absolutely important that we understand how deepfake is created. And that is why we are discussing in this video only how synthetic data is generated. It's not all the methods that we're discussing, but we are looking at 10 best methods which can be used, and sometimes these methods are combined to create some complex synthetic data that is difficult to differentiate between a real data. But now let's start by first of all defining what synthetic data is. Now, synthetic data is artificial data that mimics real-world data but does not contain any of the same information that the real world has. In other words, the data is not real, it's fake, but it looks closely similar to a real-world data set. And that data can be numeric, textual, it could be audio, it can also be a video or another form of the data. And sometimes, if it is done well, you can find it very difficult to differentiate synthetic data from real data. Now, synthetic data is generated using algorithms and simulations based on generative artificial intelligence technologies. But that's not the only way. There are even simpler ways of generating synthetic data that does not involve generative AI. You know, some mathematical formulas can help you to generate synthetic data that will look closely like a real-world data. We'll discuss that later. But just know that synthetic data is generated using algorithms. Basically, you give instructions and the data is generated. Now, synthetic data is used in a variety of fields, including research, including testing, new development, and even machine learning research. This is what I'm saying. So we'll look at some of these use cases today. The benefit of synthetic data includes validation of mathematical models. So this is very important. You have developed a mathematical model and you don't have the real world data to validate the models. You could use synthetic data. If you know how the data should look like, you could use synthetic data to validate the mathematical models. Another way that synthetic data is used, or the benefit that is used, it is used for training machine learning models. So we all know how complex it is to acquire data sometimes. It could be very costly or it could be very dangerous. Like it may create hazard or very risky to individuals that will be involved in data collection. So if we can generate synthetic data that will look very similar to the real data, then synthetic data can be used for training machine learning models. I know sometimes even when you train a machine learning model with synthetic data and working very well with good accuracy, and by the time you apply it to a real world problem, it will start misbehaving and performing poorly. But that does not rule out the fact that you can use synthetic data to train your machine learning models. Synthetic data can also be used to test and improve algorithms without risking the privacy or security of real-world data. I mean, if you are involved in data collection process, you understand what this means. Like people, real data, people information, people privacy, and some secret information that are protected. Maybe security-wise, it's not good to reveal those data to make them public, but you still need the data to train or improve an algorithm. So synthetic data can come in handy. You can also use synthetic data to augment existing data set, especially if the original data is limited or biased. That is where synthetic data can come, so that you can balance the data, or to deal with the bias within the data set, or increase the data size. So if you only have 2,000 and you need like 5,000, you can actually use synthetic data. Work out the model on how to generate the synthetic data that will look very similar to the data set that you already have. So augmentation of existing data set is one benefit of synthetic data. Synthetic data could also be used to sidestep privacy issues that arise from using real consumer information. So you don't want to go and get the real consumer information and use them in training your model. So yeah, by relying on synthetic data, you're already sidestepping that. Now, it also helps to reduce cost. So sometimes it can be very challenging to acquire data set. Whether the data set is already collected and stored somewhere, you need to pay for the license, or if you need to go meet real people, collect the data, and then come and train your AI model or come and use it for your purpose, it can be very expensive. But you can work out a model, a generative AI model, or a kind of an AI model basically to generate that data for you. And there are a lot of considerations, but I don't want to deviate by going into those considerations. I just want to focus on giving you some of the benefit of using synthetic data now. Now, it can also help to speed up business processes. So it can take time sometimes to generate real-world data. It could take up to, depending on your project, collecting the data may take a while, especially if it is a time series data that you need the data for up to 1 year and you are generating it from, you are collecting the data from scratch. So that could take some time. Imagine if you want to mount sensors to collect data to model some maybe hair quality or whatever. And that means you need to leave the sensors there running for some time, and that will delay business process. Because the sensors are running, you are incurring costs and it's still delaying you. Maybe the idea if you need 2 years data set, so the sensor needs to basically run for 2 years. And that means that by the time the data set becomes available, the idea is already outdated. Maybe other businesses are taking over, and etc. etc. But if you could generate the data synthetically, then why not? Now, how is it being used? Like I said, it can be used to find and fix problems in AI models. Synthetic data can also, you can create synthetic data for a variety of applications like I've mentioned before, including tabular data, natural language processing, and even time series data. Yes, the data needs to be indexed against time. That is why it is called time series data. But in real world, like the sensor data I mentioned before, it will take some time to accumulate this data. But if you've gotten the data points, maybe just 100 points or whatever, you can actually be able to, kind of extend that data with synthetic data to the level that you think is sufficient for use in your model or in your use case. And synthetic data can also help us to comply with regulations such as the GDPR, privacy laws, by removing sensitive information from the data, and then we can use to train our models. Now, the first method that I want to talk about, and let me say that this is by no means arranged in any order at all. It's just randomly arranged. So this is the first one I'm talking about here. It's random sampling. And what is random sampling? In random sampling, it involves generating data by randomly sampling from a specified distribution. And you can use Gaussian or uniform model or any other similar model that you want. Like I said, I want to be brief. The video will be too long if I go into details and example here. But in upcoming videos, I will implement some of this in Python so that you can take and use. Now, the use case here, it could be like it can be used for any simple and quick, project, like for basic synthetic data needs. Yes, so there are a lot of areas that you can use for that. And like I said, the pros here is that it's fast to implement. Yes, fast and very easy to implement. Maybe by the time I implement this in Python, you understand it better. And then the cons here is it may not be suitable for complex or high dimensional data set. Yes, so this is very important. It may not be suitable for complex project, but if you are working on a very simple, you just need a very simple data, then yeah, random sampling may work for you. And this is the mathematics behind. So basically, you have x, and you use a kind of formula like this using probability distribution. You know, the data is generated by sampling from your x1 to xn, such that your xi is no probability component of original x, and that can be from 1 to the number again. For example, here we have uniform distribution x, and you use uniform of a and b here, and also the formula for normal distribution is there. So if this gets you confused, maybe we will implement it in Python. Always it's easier. Now the second method is bootstrapping. And what is it? It's a kind of statistical method where new samples are generated by resampling from an existing data set with replacement. So to use this method, you need to have some existing data set, so that by the time you resample from that existing data set, synthetic data can be generated, and at the end of the day, the data will look very much alike. Now, the use case here is it's going to be useful when you want to create variation of existing data set without assumptions about the underlying data distribution. So you can use bootstrapping here. And the pros is that it's also simple and good for small data sets. And yeah, the cons here is that it's limited to the structure of the original data, obviously, because you are kind of bootstrapping, you are resampling your existing data. So it's limited to the structure of the original data set. So it does not introduce new patterns. So if previously the data has, maybe if it's an upward trend, then it will continue with that upward trend. If it's downward trend, then it will continue. Or if it was flat, you know, that kind of a trend will be observed, and the pattern will remain the same basically. So that is one challenge for this bootstrapping method. And this is the mathematical method of using it. You can see that you have a data set D that consists of x to xn, and you can be resample to get your data set D asterisk using uniform or any other method here. But what I was saying is that each bootstrap sample D asterisk has the same size as D. So you see why we say the structure is confined to the existing structure, but elements are repeated due to sampling with replacement, and it is used to estimate confidence intervals or generate more data for statistical analysis. Now the third method I want to talk about here is data augmentation. This is very key again. Now this involves transforming existing data points through techniques like rotation, flipping, scaling, and even cropping. And it is commonly used in image data, as you can imagine. If you are used to even editing image on your phone, you will see that yes, if you if you take a picture and then you crop, you save it, you've got another sample of the picture. So you can crop up the edges, maybe you can flip it, rotate it, flip it vertically or horizontally, or even scale it. So this is a very layman way of explaining this. You have another copy of it. If you just do save as, you have another copy of the same picture you have, and you can also rotate it. So by a certain angle, yes, you can rotate it by certain degrees basically. So you have another copy of it. Just use save as. But this is, you are doing this manually, though the program is running behind. But you can also write your program in Python to do same thing, so that if you have only 50 images and you need like 150 images or 200 images, you can use this method to augment the images. So it's widely used in computer vision to expand small data sets. Yes. And yeah, I will leave this for the implementation part so that we can discuss in detail. The pros here is that it can greatly increase data set size while preserving key properties. You see that when you are doing all those things to the images, if you take the image, you are cropping it, or you are kind of flipping it, or you are doing this, the key properties of the image is still that despite the fact that the object may now appear upside down or at a particular angle if you rotated it, or you rotated it, or maybe bigger or smaller if you scale it up or down, but it still works. It still retains those key properties of the original data set. Yeah, this is limited to domain-specific transformation, and you can't use it to generate completely new data points. Like we said, you need to have the picture before you can actually do that. But that's why the fact that I'm using picture here. Yeah, the image, you need to have an image at least before you can actually be able to do that. And so what do I want to say here? Yeah, so it's domain specific. And by the way, this is one of the examples that most of the deepfake detection model today are not effective because they can perform very well in a specific domain or in a specific data set, but then fail woefully when you take it to a differently entirely new data set or in different use case. And yeah, so this is how data augmentation works. So like I said, it applies transformation to existing data to create new samples. We mentioned some of the data. It could be rotation, cropping, scaling, or even flipping. And so yeah, the mathematical formulation is that for each original data point xi, you generate synthetic data xi asterisk using a transformation t. So xi asterisk, that is that their synthetic data is equals transformation of xi at a theta, at an angle theta. Now where theta is represent the parameters of the transformation. So whether it's for rotation or could be a scaling factor as well. So primarily people will think that the theta there represents just an angle, but that could be a scaling factor as well. Yes. And let's look at this example here. In image augmentation, transformation include like rotation, scaling, and flipping. And you can see the formulas there as well. So by the time we implement this in Python, if you are not yet familiar with this, you understand this more. The fourth one here is generative adversarial networks. This is very important, and I will dwell on this more, especially when we come to the implementation. But for now, I just want to talk about it briefly. So GANs, or the generative adversarial networks, consist of two neural networks. That is a generator and a discriminator, and they are competing with each other. The generator creates synthetic data and try to fool the discriminator. The job of the discriminator is to try and to distinguish between the real and the synthetic data. So I don't know whether you get the point, but that is what it is. There are just two neural networks. One is the generator, the other is the discriminator. The generator is generating fake images but try to fool the discriminator that this is a real image. And then the discriminator begin to say, no, this is not a real image. But in the process of doing that, the generator is learning from the discriminator feedback, therefore improving the quality of the generated data over time. And that is why when it comes to GANs, you realize that once your hyperparameters are tuned properly, it improves over time. So the number of, as you continue to train, the number of epochs can actually, maybe the higher you go, the better the image becomes. So yeah, it depends on other factors as well. But yeah, that's why when GANs are trained for longer hours, you see that the image can generate some high quality images that will look very much similar to the real image, and so it begins to fool the discriminator. So this is powerful for generating high dimensional complex data, such as images, audio, and video. So this is really important. Most of the generative AI tools you see today that is used for generating image, or that is used for generating music or any other thing, it may actually, it might have been built from GANs, yes, but I mean, most of them are proprietary, so they are private. They don't. Their source code is not public, but yeah, some of them could be using GANs. We don't know. There are other methods. Don't forget about that. Now, the benefit of this is that it can produce realistic, high-quality synthetic data. So this is what we're talking about. It's just training. Has the two guys continue to play the game, say, guess, is this a right or is this a real or fake image? And the discriminator say, no, this is fake. Then generator improve a little bit. And then it goes and it goes and it goes and they continue until the generator can generate high quality synthetic data that the discriminator is not able to, is no longer able to distinguish it as a fake image, and you will just say, oh, this is a real image, meanwhile it's a fake. So the generator has successfully fooled the discriminator. Yes, this can be very difficult to train, and it's prone to issues like mode collapse. So we'll talk about this in more detail, but yeah, GANs can misbehave. Yes, they can misbehave. So apart from having, having the right parameters, apart from tuning your parameters right, you also want to make sure that you have the right compute power. By the way, it depends on, if you run it on the cloud, you may get different level of accuracy. If you run it on a local device, you can get different level of accuracy. And if you are implementing it using PyTorch, which is what we're going to do at some point, you realize that the accuracies can differ, widely depending on the device you use, and that's why compute power is very important. So maybe if you have PyTorch will run on CPU fine, but if you have a GPU, it's always better. It's faster, and so yeah, you need to choose where you want to do it. But doing it on the cloud, you have to pay. Whether you are using Google Colab, and then you need to pay for it, and it needs to run for a longer time. Or if you are using it locally, then you know that your computer needs to be very strong to do this. Consider the speed of the computer, the RAM. Yes, the RAM need to be very good, and yeah, it need to basically, you need a high spec computer to do this as well, because it can run for long and also consume energy as well. So these are things that one should take note of about GANs. And let's look at the mathematical formulation behind it. So like I said, GANs involve a generator G and a discriminator D, where G generates synthetic data and D distinguishes real from synthetic. Now, mathematical formulation is that G maps random noise Z, like approximately P of Z, to synthetic data X. So your X is equals to G of Z, basically, generated by a generator. And the discriminator D outputs the probability that the sample is real. So this is what we're saying. So your D of X is equals to the probability of whether real or fake. So it's going to be normally 1 or 0, basically. This is what you do. And so GANs actually optimize the following objective formula you can see here. We'll talk about this formula in detail. I don't want to make this video too long. So time will come that we'll break down this formula, but basically it's a combination of the generator and the discriminator, as you can see. If you see, taking the log of it and making sure that it's 1 or 0. Let's go further. Now the next method, which is the number 5 on my list, is variational autoencoders, or you call it VAEs. Now, VAEs are neural networks as well, but they encode input data into a latent space, then decode it back to the original space, generating synthetic data from the latent distribution. So how this works is that, well, I will show you the mathematical formula in a moment, but this is good for generating new data points that resemble the original data set. So you can see that if you want your data set to resemble the original data set, and depending on your project, you may want to be considering VAEs. But I mean, like maybe GANs. But yeah, let's look at the cons, the pros here. It is stable to train compared to GANs. It is also effective for low dimensional data. Again, if you are looking for high dimensional data, you may want to prefer GANs. But GANs are difficult to train. However, if you need something that will is more stable, then you may want to be using variational autoencoders, because you want it to generate synthetic data from the latent distribution which resemble the original data as much as possible. And the concept is that generated data may be less sharp or realistic than GANs. So that's the reason I was telling you that most of the generative AI tools today rely maybe using GANs basically. I don't want to say rely on GANs, but as you can see, I mean, even OpenAI, you see all the time they're asking them. Their code is not public, so you don't know what they're using. Despite the fact that their model is one of the best generative AI we have today, but yeah, everybody's keeping it private, so we may not know, except someone is open source. Now this is how variational autoencoders works. So like we said, they learn a probabilistic latent representation of the data and generate synthetic data by sampling from the latent space. And this is the formula here. You know, they try to optimize the evidence lower bound, elbow. And if you are hearing this for the first time, don't worry. When we come to implementation in Python, we will take time to explain this and do it in more detail. So yeah, just watch out for that video. But this is the formula, and these are the definition for the formula. You have it there, the variational posterior, and then you have prior on latent variables, which is here, and then you've got your KLD or your KL divergence, as you can see it here now. And the encoder maps data X to the latent distribution, and the decoder generates synthetic data. So this is what is happening here. So it's basically encoding and decoding. That is what Vase is built upon. Yes, so to keep it brief, maybe we can leave it at this point and then go to the next one. The next one is smooth, or what we call synthetic minority oversampling techniques. Synthetic minority oversampling technique, or smooth. Now, description: that is a method used to address imbalanced data set by generating synthetic samples for the minority class through interpolation between existing data points. So this is very important, because if you use a kind of imbalanced data set to build your model, to train your model, then the model will be biased. The model will not be balanced. It will behave. So most AI basically depends on the data set that you have, on the data set that you train on. Is like the original definition of GIGO, garbage in, garbage out, is what AI does basically. So if your data is suffering from imbalance, you may want to use smooth to make sure you balance it up, so that you are able to get a model that is also balanced. Otherwise, the model itself will be imbalanced. And there is a lot of things to be said about this, but I don't want to dabble into that again. Let's just focus on the purpose of this video to see how we can minimize its lane as much as possible. But yeah, it is common in classification problems with imbalanced data set. Yes, and there are a lot of classification problems we can talk about. And yes, it is simple and effective for balancing data set. So remember that if your data set is not balanced, what you want to go to first is this smooth, and it's simple and direct. Yes, you don't want to go for something bigger or more complex when that all that you want to address is imbalance within your data set, and you're using for classification especially. Now, it only works for structured data, not good for generating truly diverse synthetic samples. So this is the challenge here. Like I said before, if you are working on just classification problems and your data set is suffering from imbalanced data set, then it's affected by imbalance, then you want to just use smooth to address that problem. But remember that this is only working for structured data. So if your data is unstructured, such as those properties of big data, then you will not be using this. Think of other method, probably the one we've already discussed above. And it's not good for generating truly diverse synthetic samples as well. Now, here is the mathematical formula behind. I promised that I was going to be giving you some mathematical formulation behind for all of the methods that we're talking about here. So smooth generates synthetic samples for minority class by interpolating between existing samples, like I said. The mathematical formulation is that two samples xj and xi and xj, a synthetic sample x asterisk is generated. has this formula you can see here. So look at, we're assuming that xj is balanced, xi is so basically, I mean, we're considering two samples, xi and xj, and so we generate the synthetic sample x asterisk, as you can see on the formula here. And we basically want to ensure that the new sample lie along the line segment between xi and xj to improve the representation of the minority class in imbalanced data set. This is theoretical and can be quite complex, maybe for some people to understand. But yeah, we will implement this in Python for you to understand. We're going somewhere on a journey. At the end of the day, we will try to build what we call a defect detection model. This is an extremely challenging task to do, to be honest, because AI is advancing very fast, and the bad actors using these tools to create deepfakes, to create synthetic data, they are also improving by the day. So even a deepfake detection model that works effectively today may not work effectively tomorrow. This is a kind of changing space, and at a very fast pace. But we'll try to model something that at least can differentiate between a real video and a real content and a fake content, basically. But we need to lay this foundation first. Now, the seventh method here is agent-based modeling, and this is a kind of simulation-based approach where individual agents with defined behaviors interact in a virtual environment, producing synthetic data based on those interactions, basically. So I believe that maybe you understand the concept of multi-agent modeling. This is the concept that is used here, and I don't want to waste time saying a lot here. But yeah, it is used in fields like social science, economics, and epidemiology for simulating complex systems. But again, this is not something that everybody will be familiar with, especially when they are beginning to use social science concept here. And but yeah, multi-agent or agent-based modeling can be used to generate synthetic data when you don't have the original data. And I believe that you guys know the concept of digital twin. This concept can be used as well, especially when you don't have the real data set, but you still want to model a physical asset. You can generate synthetic data to use within your digital twin model. Now, it provides detailed rule-based synthetic data. So imagine writing a lot of rules because you want every agent to behave this way. So most agent-based modeling systems depend on rule-based system, basically. So is the method for generating synthetic data. It is rule-based and it has to be detailed so that the agent know what to behave at a particular point when the rule is applied. Now, it requires domain-specific knowledge to model agent behaviors, and that is true because I mean, look at how many of you even know what is called what was it again? Epidemiology, or even social science. So if you are from STEM background, you've always been STEM, you're always computer science, you will not understand some of this concepts from social science. Their research is quite different. They will talk about the onion method, they will talk about what again? I mean, they will talk about different concepts, and you'll be struggling to understand them. So that is why domain knowledge is needed here. Domain knowledge is needed here to be able to use this effectively. Because when they come to start describing their onion method, you hear they talk about things like positivism, pragmatism, induction, deduction, critical realism, and etc. etc. It's just so complex. But these are for business research, social sciences, and yeah, even in economics, econometrics. So, but if you don't have the domain knowledge, then you may not be able to use agent-based modeling. However, if you have the domain knowledge, you'll be able to use this, and that is why it is good for people that are into multidisciplinary research. Yeah, they can use this method very well. and but don't forget the limitation. So this is how agent-based modeling works for generating your synthetic data. So like I said, it simulate interactions of autonomous agents in a system to generate synthetic data. So like in the US, where you see autonomous vehicle going back and forth like that, being popular like that, they probably might have started using agent-based modeling to see how each of the, it's not probably, in fact, this is what they must have done. That's why there's a new concept coming up like LLM multi-agent modeling. So you are not just giving them rules alone, but this time around you are using large language model to instruct the agent to behave at a particular time. So when you don't have a rule, they should be guided by the LLM. This is another new area that is emerging and it's very interesting. We have a research group that we're working on. But yeah, that is where LLM can come in as well. But generating synthetic data through this agent-based modeling, like I said before, it can be useful for different scenarios. It can be used for different scenarios. Maybe when the agent can behave, when they do the right thing, you reward them. When they do the wrong thing, you penalize them, which is the concept that is used. And in the process, you can generate truly synthetic data that can mimic real world data set. And this is the mathematical representation here, where AI of t represent the state of other agents within the data set. But you also have the agent AI at t, because we said here that let here. So I don't know. Let me see if I can bring this up. Yes, maybe here. So this, I don't know if you can see this now. So AI of t represents the state of agent I at time t. The state evolved based on rules F. Yes. And let me see. Yeah, probably I can stay with this. Yeah. So this is the formula here. And so this agent, as you see, it depends on this and with the environment here, and we've said that this is the state of other agents. So there are lots of agents normally, and this is where the concept of multi-agent modeling comes in. And we talked about LLM as well, but not in this video. We're not going into detail with that. Another presentation comes for that one. So the fact is that agents interact according to predefined rules. We've said so, and they're commonly used for simulating population behaviors. So current system, the agent deal with these predefined rules, but just know that with LLM, not all the predefined rule works again, because LLMs will study the environment and be able to instruct the agent on what to do. Maybe in that kind of scenario, like there's a separate video coming for that. So let's move further to the next step. We're almost there. This is the 8th method. We're talking about 10. So the 8th one is synthetic data via rule-based system, very similar to the agent-based modeling. So data is generated based on predefined rules or mathematical models, ensuring the synthetic data matches known characteristics of the real-world data. So you already know the kind of data set you want to generate. You can use this method. So the difference between this and the number 7 is that these are not agents. Yes. These are not agents, but you do know the data set, that the data set is real, so you can introduce some rule or some mathematical models to ensure that the synthetic data you are generating is exactly the same with the real world data, or very closely resemble the real world data. This is used in industries with strict control over data features like finance and healthcare. Yes, and a lot of examples can come here. But yeah, it can closely resemble real-world patterns when rules are well defined. So here the focus is on getting the rules right, and domain knowledge is needed as well, because the rules are generated by the domain expert, which if they are not expert, they may give false rules, and so that means the synthetic data generated will not be accurate as well. And this is limited by the complexity and comprehensiveness of the rules, like I said before. So if it's a very complex system, I'm imagining how many rules do you need to write. So there was a project we worked on, and this was using knowledge graph, and we needed to augment the data. and using this method. So we have to generate like 149 rules. This is a lot, but that was just for a small sample of data set. So you can imagine if you are going for a much complex much complex project, then it will get so difficult to write all the rules and that they're accurate. But it's one of the ways of generating synthetic data. And this is the formula. Basically, x depends on r of theta. R is the rule. Theta here is the parameters defining the rule, and it could be anything at all. So I just put theta here, but the rules depend on your own scenario. Healthcare generating patient data with predefined distribution for age, gender, and symptoms can be a very good example for this. Now the number 9, we're nearly there, is noise injection. Noise injection. Noise injection. Now this involves adding random noise to real data to create variations, and this can be done at feature or instance levels. So basically you are adding noise to it, and this is one of the methods that is used today. So that even when you understand the pattern of how synthetic data is generated, and you are using that to build a defect detection machine or defect detection tool, by the time the creators, the bad actors, inject some noise, it will confuse your model altogether. And so that's why a lot of people are asking questions if the best way to distinguish real content from synthetic content is to use maybe watermark. So watermark, not like visible watermark per se, but watermark that are hidden to the human eye but visible to AI models. That is a very interesting area to look at, you know. This noise injection is suitable for augmenting existing data set as well. So yeah, think about it if that's what you want to do. Like I said, they can generate an image, a video, or even an audio, but introduce the noise that still remains silent. So the noise is introduced, is injected, but they keep it silenced, though it's still within the content, and you cannot hear it with the ear, with the human ear, to detect that, oh, this is a noise. But yeah, that is why it is difficult, and the line between real and fake content, or between real content and deepfake, is getting blurred by the day with the complexity and the advancement of AI. But yeah, we need to keep researching and finding the way forward. Now we've got pros here as well. It is simple and fast for structured data. Good. And yeah, it may degrade the quality of noise. It may degrade the quality if the noise isn't properly controlled. It's noise basically. So if you think about signal modeling, or if you are editing audio or something, look at the wave. By the time you introduce noise, it can go very wide and wayward. So this is the formula. Basically, you've got your original data set, original data X, and you want to generate X asterisk, which is the noise, which is the synthetic data. You just introduce noise here, basically, and the noise is approximately this. So yeah, it ensures that the synthetic data is close to the original data. But because it's noise, imagine if the data set is large, you may not be able to control the level of the noise again, like we said before. So the control the noise can be very difficult. But that can still help you to models generalize better. It can help models to generalize better, because in real world scenario, those noise are expected, right? So apart from having the real data set, introducing noise may actually make the model to perform well in real world data set. So 10, and finally, differentially private synthetic data generation. And this uses privacy preserving algorithm to generate synthetic data while ensuring that individual data points in the original data set cannot be reconstructed. Yes, at least the focus here is that privacy data or privacy element within your data set is being preserved while generating the synthetic data, and the individual data points generated within the original data set is supposed to look very similar to the original data set, but it cannot be reconstructed. And this is critical for generating data in privacy sensitive domains like the healthcare or finance. So most of you doing research in healthcare, you want to build an AI model for healthcare and you don't have the data, think about using this method. Again, we'll also implement this in Python, at least maybe the basics, so that you can take it forward and then advance it for your own use case. So watch out for this video coming. And yeah, it ensures data privacy while generating synthetic data. So especially if you are in the UK or in Europe, you know what GDPR can do to you. People data need to be protected. So yeah, maybe you should be going for this option. And yeah, so the quality of generated data may be lower due to privacy constraints, because there are some data that you can no longer use from the original data set due to privacy constraint. And so yeah, the quality of the resulting synthetic data may actually not be as good as the original data. This is the mathematical formulation for this. You have your D and D at the data set differing by one record, and your A is the synthetic data generation algorithm, and this epsilon is the privacy budget. But yeah, it adds noise to output or intermediate step to protect individual data points, and it also balances privacy and utility. Yes, so it will be interesting when we introduce it, and maybe you can take that. We also intend to share that publicly on GitHub, so you can download the code and use it for your purpose. But yeah, now we have talked about this. What do you think is the best method? Which method do you think is the best? Well, determining the best method can be critical and can be difficult, but GANs are generally considered the most powerful method for generating realistic, high-quality synthetic data, especially for complex data like images or audio. Even the original creators of GANs, they said that, and ever since then, GANs has been improving, and there are different variation of improving it. But yeah, or of generating data, synthetic data using GANs. We're going to implement this, but yeah, most people use GANs despite the complexity. They just want to increase the training time, improve the parameter tuning, use the best learning rate, etc., to be sure to get the best out of it. But yeah, maybe GANs are the best, or maybe they are not. And this is also followed by VAEs, which are good alternative when stability in training is needed, like we said before. But GANs tend to outperform them in producing realistic samples. So it's up to you. If you have got the compute power and you have the expertise to actually train GANs well, then maybe you want to go for GANs. Otherwise, you can come down to VAEs. That means you are trading quality for simplicity. It's not, VAEs are not that simple though, but yeah, they are just less complex when compared to GANs. But you can agree with me that they are also more difficult compared to the other methods we've discussed. Now, for imbalanced data set, you may want to be using smooth, like we said before. Smooth is actually important so that the imbalanced data set is addressed. And if privacy is a concern in your project, then differently, private synthetic data generation is the best choice. Differentially, private synthetic data generation is the best choice for you. Ultimately, this is my final word. The best method depends on the type of data, the complexity of the problem, and the goal of the synthetic data generation. I hope this has been useful. Our next video will focus on implementing each of these models within Python. Where necessary, we use PyTorch because TensorFlow is being phased out. It's no longer going to be compatible with Python 3.1 period, I think. Yeah, and TensorFlow again doesn't work on some Windows or new version of Windows again. So we would like to where we're using any deep learning model like the GANs, we'll be using PyTorch. That will be implemented. And yeah, after that, we will try to now build a model, first we've exposed or introduced ourselves to the method for generating synthetic data. The next thing will be to build models that can generate synthetic data, and then after that we'll now build models that can detect synthetic data, and let's see where that takes us to. I mean, this is for me, this is the best thing to do in this world and time. If you think about what the bad actors are doing with deepfakes around the world, from South Korea to the UK to Europe to the Americans, they are going into everywhere. Bad people are using it for misogyny, etc., etc. A lot of bad things are happening. So if we have, our goal is to create a kind of an open source deepfake detection tool that can be updated regularly on a real-time basis and collecting feedback, and then the model should improve on that. So the journey is fine. If you can follow us along, at the end of the day, I hope you will not regret your journey, and we'll be sharing the result with you as well. So thank you for joining today, but yeah, see you next time. Bye bye.